In this video, we will discuss soft computing module 1. We will cover certain topics from this module. Topics covered in this video. First, we will start with what is fuzzy logic components. We will try to understand this using examples. What is crisp set? How fuzzy logic is different from traditional logic. What is degree of membership? What is fuzzy relation? Composition of fuzzy relation. Then we have fuzzy inference system and defuzzification. So in this video, we will try to understand what is soft computing using example, what is fuzzy logic, traditional logic, how fuzzy logic is different from the traditional logic. We will try to understand this using example. Then what is crisp set, degree of membership, then fuzzy logic operators, fuzzy relation. Then we will try to understand fuzzy relation using another example. And next we have composition of fuzzy relation. Here we will try to understand this using an example. Then we have fuzzy inference system. Then we have different soft computing tools. So first we will start with what is soft computing. Soft computing is like a set of computational techniques that try to imitate how our brain works. Soft computing is a field of computer science that focus on the development of algorithms and computational methods inspired by human awareness and reasoning. Soft computing is more flexible. It can handle things that are not perfectly clear. It is good for dealing with situations where things are little uncertain or not straightforward. For example, we are trying to teach a computer to recognize different categories of animals. Soft computing allows computer to learn and make decisions even if information is bit fuzzy or not 100% clear. Using soft computing techniques, we can solve problems that are difficult to address using traditional methods. Now next we have what is fuzzy logic. So first we have a little difference between traditional logic and fuzzy logic. How fuzzy logic is different from traditional logic, that is also known as classical logic. Traditional logic is based on binary values, either true or false, either yes or no. There is no in between. For example, we have any element, either it belongs to a set or it does not belong to a set. There is no in between. But in case of fuzzy logic, it allows the representation of partial truth. Fuzzy logic is connected with human reasoning. It is like teaching a computer to think a bit like humans do, make decisions in situations involving uncertainty or imprecision in a flexible way using linguistic variables, rule-based reasoning that resemble common sense thinking. So here, fuzzy logic allows the representation of partial truth using linguistic variables and rule-based reasoning. Here, partial truth means expressing how true is something in more flexible way. Fuzzy logic is introduced in 1962. It is a mathematical approach to computing and reasoning that deal with uncertainty and imprecision, and values are indicated by number, and range we have from 0 to 1. So there is no only yes, no or true, false. We have range from 0 to 1. We can take values from 0 to 1 in between. So we can take in between values. But in case of traditional logic, there is either yes, no, true, false. There is no in between. But in case of fuzzy logic, we have in between. We have range from 0 to 1. For example, we have a glass and it is half filled with water. So in simple way, we can say either the glass is half empty or it is half filled with water. There is no in between. But using fuzzy logic, there is in between. We can say like this: water level is at 0.6, 0.5 or at 0.3. So fuzzy logic allows the representation of partial truth. So here we have simple definition for fuzzy logic. It allows for the representation of partial truth or degree of truth by using linguistic variables and approximate reasoning. Fuzzy logic is used in different areas, in control systems, decision-making processes, data analysis, pattern recognition, in artificial intelligence. Now we will try to understand fuzzy logic using example. For example, we have to describe the ripeness of bananas. In traditional logic, you might say if banana is completely yellow, it is ripe, that is true. And if banana has somewhat green, then it is unripe, that is false. But in case of fuzzy logic, we can say it in different ways. Now, in fuzzy logic, if banana is completely yellow, it is very ripe. If banana is somewhat yellow, then it is somewhat ripe. If banana is half yellow and half green, then it is partially ripe. And if banana is mostly green with a hint of yellow, then it is somewhat ripe. And if banana is completely green, then it is very unripe. So you can see we have fuzzy set, very ripe, somewhat ripe, partially, somewhat, or very unripe. So this is called fuzzy set. Fuzzy set is like category that is not strict. So in classical logic, an element either it belongs to a set or it does not belong to a set. Either 1 or 0, true or false. There is no in between. But fuzzy logic allows the representation of partial truth. For example, here you can see we have for this banana example. Here using fuzzy logic, we describe the ripeness of a banana, and here you can see we have, and here you can see we have a number of cases. But in case of traditional logic, there is no in between, either yes or no. Another example, suppose we have temperature control in air conditioner. So in traditional logic, when the environment is hot, we will on AC, that is true. If it is cool, we will off AC, that is false. So there is on, off, true, false, there is no in between. Using fuzzy logic, we have a number of cases: hot, somewhat hot, neither hot nor cold, somewhat cold, or it can be very cold. Now you can see what is crisp set. Element either belongs to a set or it do not belongs to a set. So we have binary membership. So in crisp logic, we have binary membership. When element belongs to a set, it is true. If it does not belong to a set, it is false. For example, we will consider a crisp set of even numbers. In classical logic, even number is defined as a number that is completely divisible by 2 without leaving any remainder. For example, we have number 4. It is clear that it is even number, so this belongs to a set. For example, we have another number that is 5. It is clear it is not. So number 5, that is not a even number, so element do not belongs to a set. So in crisp set, either element belongs to a set or it does not belongs to a set. There is no in between. But in fuzzy logic, fuzzy set allow partial membership, like you can see in the banana example. In fuzzy set, we assign degree of membership to each element in the set. Degree of membership indicate the range, or we can say degree to which an element belongs to a set. It is a measure used in fuzzy logic to express the extent to which an element belongs to a fuzzy set. So in fuzzy set, we will assign a degree of membership to each element which represent, that indicate the element belongs to a set. Then we have degree of membership value. It is in between 0 and 1. 0 clear mean that element does not belongs to a set. 1 mean that it is fully belongs to a set. Then we have another values. Then we have other values in between 0 and 1, 0.1, 2, 0.3, 0.4, 0.5, up to so on. Next we have fuzzy logic components: fuzzy set, membership function, fuzzy rules, fuzzy inference system, and defuzzification. So first we have fuzzy set. So first component we have fuzzy set. In classical set, element either belongs to a set or it does not belong to a set. But in fuzzy set theory, elements can belong to a set to a certain degree, that is degree of membership, and the value is expressed in between 0 and 1. Next we have membership function that define the degree of membership of an element in the fuzzy set. We will understand this using an example in the upcoming slides. If-then rules that express relationship between input and output variables. They use linguistic variables and fuzzy operators to make decisions. Next we have fuzzy inference system. So fuzzy inference system process input data and produce fuzzy output. It involves fuzzy set, membership function, fuzzy rules, inference mechanism, and certain rules. Last we have defuzzification, that is the process we use to convert fuzzy output into a crisp value. So earlier we uploaded a video, that is Neuro-Fuzzy hybrid system for water heater control system, and we cover different topics like what is fuzzy set, membership function, fuzzification, defuzzification, fuzzy inference system, fuzzy rules. For more details you can check this video. For example, you can see here we also did neural network integration. So for more details you can check this video. Next we have different fuzzy operators. We have union, intersection, complement, algebraic sum, algebraic product. So first we have union operator, that is denoted as union of two fuzzy set A and B, that is A union B. A union B, this represents the fuzzy set containing all elements having higher degree of membership in either A or B. Next we have intersection operator. It is denoted by A intersection B. So this represents the fuzzy set containing all elements having high degree of membership in both A and B. Next we have complement operator denoted by this. A complement represents the fuzzy set containing all elements that do not belong to set A. Next we have algebraic sum, that is denoted by this, and it is computed as A plus B minus AB. The last one we have algebraic product, computed as A into B. So next we have fuzzy relation. In fuzzy logic, fuzzy relation describes a relationship between the elements of two fuzzy sets, where degree of membership in the relation is expressed as fuzzy values. Fuzzy relation is represented as a matrix, or it can also be represented by ordered pairs, where each pair consists of elements from two different sets and have degree of membership. Here you can see fuzzy relation are xy. We can represent this via matrix n into m. So here you can see this is the n into m fuzzy matrix. Here we have two sets x and y, and you can see the elements for x, x1, x2 up to xn, elements for y, y1, y2, ym, and here you can see this is the fuzzy matrix that represent the relationship between these two fuzzy set. And here you can see each pair contain the elements of both set x1, y1, x1, y2, x1, ym, then we have x2, y1, x2, y2, x2, ym, up to so on. Now we will try to understand fuzzy relation using example. So for this example we will calculate the fruit sweetness in a grocery store. Suppose we have set of fruits x, set of sweetness level, that is y. Now you can see for this we have a fuzzy relation. So suppose we have three fruits, apple, orange, lemon. Then we have sweetness level. Then you can see we have sweetness level sweet, moderate, sour. Then we have degree of membership 0.8, 0.5, 0.2. So here we have the fuzzy relation apple sweet 0.8, orange moderate 0.5, lemon sour 0.2. So in this fuzzy relation, apple is considered sweet with high degree, that is 0.8. Orange is considered moderately sweet with a degree 0.5. And lemon is considered sour with low degree of membership, that is 0.2. So among all we have sweetest, that is apple 0.8. So another example from book you can see here. Fuzzy relation describe a relationship between elements of two sets. For example, here you can see we have a fuzzy matrix, and you can see the graph for the fuzzy relation. So first you can see x1, x2, x3. Another set we have y1, y2, y3. So here you can see first element we have x1, y1, 0, x1 to y1 there is no, x1 to y1 0. Next we have x1, y2, that is 0.4. x1, y2 you can see 0.4. Next we have x1, y3 0.2. Here you can see x1, y3 0.2, x2, y2 0.1, x2, y3 0.6. You can see here x3 to y1 0.5, x3 to y3 it is 1.0. So this is the fuzzy relation graph. Now we have composition of fuzzy relation. So here we will combine two relations now to form a new relation. Now suppose we have two fuzzy relation R and S. You can see, so here you can see this is the new relation, that is ROS. So here you can see this is the new relation. This relation describes how elements in first set are related to the elements in third set S. So here you can see the mathematical form. R is a relation from set X to set Y, and S is another relation from set Y to set Z. Then the composition of these two relations is described by this. This is the least upper bound. Minimum is the minimum operation. X is the element from set X. Y, that is the element from set Y. Z, that is the element from set Z. Now we'll consider the composition of two fuzzy relations that is related to the fruit sweetness. Here suppose we have fuzzy relation. So here we have first relation, that is sweetness of fruits. Second relation, that is individual's preference for the sweet fruits. First relation R1, you can see here apple, orange, lemon, three fruits we have. Then we have sweetness level, sweet, moderate, sour. Then we have degree of membership 0.8, 0.5 and 0.2. Second relation we have, that is R2. It represents the individual's preference for the sweet fruits. So we have three individuals, Alex, Bob and Ron. Now you can see this is the composition of these two relations. It represents the individual preference and the sweetness of fruits. So this would calculate the degree to which Alex preferred sweetness level of apple based on these two relations. This max operator will find out the max degree of membership among these three. So here you can see first we have 0.8, 0.7, 0.5, 0.7, 0.2. So here you can see minimum value among these is 0.7. For second case 0.5, for third case 0.2, and among all we will calculate the maximum, that is 0.7. This 0.7 value represents Alex preference to apple sweetness, that is 0.7. So next we have fuzzy inference system. We can say fuzzy expert system, fuzzy models or fuzzy rule based system as fuzzy inference system. Fuzzy inference systems use fuzzy logics to represent and process the information, and their key components you can see defuzzification, fuzzification, rule based evaluation. Then you can see we have different key components. So last one we have defuzzification, that is the process of converting the fuzzy output into a crisp output, and we have different methods that we can use for the defuzzification: max membership principle, centroid method, weight average method, center of sum, center of large area, first maxima, last maxima, or mean max membership. So we have number of methods that we can use for defuzzification. Then we have different soft computing tools: fuzzy logic, evolutionary computing, machine learning, neural networks. That is given in other units we will cover in the upcoming videos. For fuzzification, defuzzification, rule base, how it all working, you can check here in this video. It is given with numerical example. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.